right, ladies and gentlemen, let's use our wonderful Dixon Ticonderoga number 2 hashtag not sponsored to do the second part of the homework. So this is Exponents Part 2, homework number 2. All right, so check this out. Here's what we got. We have a base of 2 with an exponent of 8, and that's being raised to the power of 1/3. So what you got to do, multiply this exponent of 1/3 times the exponent of 8, and that is going to give you 8/3. So with what we know how to do right now, it's going to be 2 to the power of 8 over 3. Now that could be simplified further, but with what we know right now, that's all we're going to do. And the whole purpose of that question is just to see if you can apply a rule that you already know or a property that you already know in a way that's uncomfortable. Boom, done. All right, now this one's a little tricky. Check this out. This is 3x squared. This is 3x squared cubed. So here the base is 3x squared, but I have 3 of them. All right, so this part's going to stay the same, right? But this is going to be 3 cubed x to the 6th, right? Because you have to multiply. The 3 has an exponent of 1. You got to make sure you multiply that, right? So 3 to the 4th, because I have 1 here. I have 3 there. That's 4. And then x to the power of 8. Boom, done. All right, next up, Buttercup. Here's the thing. These are common bases of 5. This has an exponent of 1. That has an exponent of m. We're going to have to subtract those. I don't know if m is positive or negative or anything. That's all we can do. Next up, bunch of negative exponents. So here's what I would do. See, I have 5's, x's, and y's. I would separate that. Normally I wouldn't write this out like this, but I'm going to write it out here. I would separate these into like 3 separate problems. Do you see? Do you see how I'm doing this? That's what I would do, because then you can just look at each part separately and you're less likely to get overwhelmed. All right, now take a look at this first one. This first one says I've got 5 times 5 in the top, and it's divided by 5, divided by 5, divided by 5, 3 times, but those are all, man, I even said that wrong. This part right here, 5 to the negative 3, is the same as 1 over 5 to the 3. So this right here is like 5 squared divided by 1/5, divided by 1/5, divided by 1/5. The short story is division is multiplication by the reciprocal, so I'm going to take the reciprocal of this. And so that's going to be 5 to the 5th, because I've got 2, now I've got 3 more. People say, hey, when you flip it, where does the sign go? Well, it doesn't go anywhere. It's like if you were going to divide, let's say 4 by 2/3. You know how you would multiply that by the reciprocal? Oops. Well, where did the sign go? Where did this sign go? It didn't go anywhere. We just rewrote it. These are exactly the same value, and that's what we did right here. Okay, so that's 5. This one, we've got both of these have negative exponents, so they're both going to do the reciprocal of both. This is going to be x to the 4th on the top, and x to the 3rd on the bottom. X to the 4th on top, x to the 3rd on the bottom. This is going to give you just plain old fancy x. Now this one, it says y to the 5th divided by y to the negative 5th. That's going to be y to the power of 10. You see, this is going to stay put, but this one we have to do the reciprocal. Exponents that are negative are repeated division. So the way you multiply, or the way you divide, is you multiply by the reciprocal. That's why it gets flipped over. Boom, done. Man, now this one right here, number 5, number cinco de stinko. Check this out. Doesn't that equal 1? Isn't that 1? 7 divided by 7 is 1, and now I have 1, 2, 3, 4, 5, 6 of them left. So that's 1 divided by 7 to the power of 6. So that's going to be 1 over 7 to the power of 6. That's it right there. Repeated division is written with negative exponents. That would be the same as this, but we don't write it that way. Just like we don't like using this symbol right here because it gets confusing. Negative exponents also get confusing. So you only leave a negative exponent if you're dealing with the order of operation, or sorry, you only use a negative exponent if you're dealing with scientific notation. All right, now this one. Check this out. This is the only number that's being divided. The others are all multiplication. So what I have is I really have like 9x squared y. So divided by 9 times x squared times y. This is the only one that's being divided. So 9 divided by 9 is 1. X squared times x squared, x to the 4th, y times y is y squared. Whereas you can see by comparison, this one's different. Now the whole thing is being divided. That equals 1. Ah, fancy that. Okay, now look at this base, x squared 2x to the 6th, x squared 2x to the 6th. Look at those exponents. This is the same as a squared times a to the negative 2. Don't you add those exponents? 2 minus 2? I'm not very good at math. I think 2 minus 2 is 0, and a to the power of 0 is equal to 1. I think this equals just plain old 1. Man, let's see that a different way. Look at this. X squared times 2x to the 6th squared. And if I rewrote this, it would be x squared times 2x to the power of 6 squared. If I rewrote it taking care of that negative exponent, the whole base is dividing. It's the same as this. It's the same as this. X squared 2x to the 6th divided by x squared times 2x to the 6th squared. Oh man, ran out of room. It's something divided by itself is just equal to 1. All right, now this one, a to the power of mn, you have to multiply those, right? Times a to the power of m. These are the same base. You have to add those. So you could write it like that. No problem right there. If you were fancy, you could write it like this. Those are the same, right? If you distribute this m times everything in the parentheses, don't you get mn plus m? All right, now, check this out. What if it was k squared divided by k cubed? Instead of that base, these bases are the same. That's the thing that's important. This base and this base are the same. Two of them on the top, one in the denominator. That's 1 over k. Would you agree with that? I hope so, because this is going to be much easier when you look at the whole base like that. No problem. Done. That's it. Dealing with exponents, man, it's wonderful. You don't want to multiply them out because you don't need to. Only do it if you have to. Otherwise, it's easier to just do it like that. Hope it's been helpful. This Dixon Ticonderoga number 2 came through like a champ. And hope you guys are having a wonderful day. Talk to you later.